Hello everybody. In this Python tutorial we're going to go over how to create and display the Fibonacci sequence. In mathematics, the Fibonacci numbers are the numbers in the following integer sequence here, called the Fibonacci sequence, and are characterized by the fact that every number after the first two is the sum of the two preceding ones. Okay, so you can start with 0, 1, 1, or you can start with 1, 1. In this case, we've started with 1, 1. Then you can see 2 is the sum of the two preceding, 1 and 1. 3 is the sum of the two preceding, 2 and 1. 5 is the sum of the two preceding, 3 and 2, all the way up to 144, which is the sum of 89 and 55. Okay, so for our first example, let's just create some simple code here that will display a Fibonacci sequence similar to this sequence here. So let's go ahead and type out the code and then we'll go over it. Okay, so we started off with two variables, a and b, and we set a equal to 0 and b equal to 1, and this is the start of our sequence. Then we created a for loop that will loop through using the range with the number 12. So this will loop through and give us the sequence to the specified number of times that we put in our range. Then we created a print statement, and inside the print statement we want to show each iteration through the loop, and then we want to show the sequence, and once we print this out to display it, you'll see exactly what this shows. The A will show the sequence starting with 0, 1, 1, and the B will show the sequence starting with 1, 1, and we use a format, and each of these sets of curly brackets are placeholders and will hold the data elements that we put in our format. So this set of curly brackets will show us the loop number. This set of curly brackets will show us certain elements of the Fibonacci sequence, and this set of curly brackets will show us certain elements of the Fibonacci sequence as well. So the loops will go here into this set, A will go into this set of curly brackets, and B will go into this set of curly brackets. Okay, so this code here is kind of the brains of what makes this Fibonacci sequence work. So let's select our code and run it. And you can see over here in the console we get our output. So let's go over our output. Okay, so this column here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Those are the times through the loop using the for loop and the range here. Now this column here where you see the A's all the way down, that is the Fibonacci sequence starting with 0, 1, 1. Now this column here with the B's, that is the Fibonacci sequence starting with 1, 1. Now in our code here we used A and B. Okay, so what this code is doing is each time through the loop, the new A will be what the old B was. Okay, so you're assigning A to the B, and you're assigning B to the old A and B. So let's go over here to our output, and let's go through this part here. A is assigned to B. Okay, so now if you look at this, you will see that, let's skip down to our loop 2. This A is what the old B was. Again, this A is what the old B was here. This A here is what the old B was here. This A, here we are at loop 5, is this old B. This A here was this old B here. And you can see the pattern. Each new A is what B was in the previous part. So this A was this old B, and you can just go catty corner like this. This A21 was this B21. This A, as we get to loop 10, was B in loop 9, all the way down. Loop 11, A55 was what B was in loop 10, and so on. Okay, so that kind of shows you the pattern for what's happening here when we assign A to what the B was. Now the same principle works here. The new B is what the previous A and B were. Okay, so again, let's go over to our code here. You can see, if you look at B here, it's the sum of the previous A and B. Okay, so B is 1. That's the sum of 0 plus 1 here. When B becomes 2, it's the sum of A and B here, 1 and 1. When B becomes 3, it's the sum of the previous A and B, 1 and 2. When B becomes 5, it's the previous A and B, 2 and 3. And the same pattern works all the way down to 144. This is the previous A and B added together, 55 plus 89. Okay, so you can see the pattern of the brains or the engine for this code here and how it works. Okay, so let's move on to our next example. And let's say that you wanted to use this code here, but you wanted to create a function and you wanted to be able to determine how many numbers the Fibonacci sequence would go to. Okay, so let's just take this code here, copy it, and put it inside a function. So we'll call this Fibo function for Fibonacci function. And the argument it's going to take is going to be the range, or the number of elements that the Fibonacci sequence will go to. Now let's paste our code in here. And inside this range here, we want to put our argument here. So when we call the function, we'll be able to determine the range. Okay, so let's run our code for the Fibonacci function. And now let's try and call the function. So inside our round brackets, let's put our range, and let's go ahead and put 12. Hit return, and you can see we get our output. The A's here, if you go down this column, this is the Fibonacci sequence starting with 0, 1, 1. And again, that's just every number after the first two is the sum of the two preceding. And you can check that. So you can see we go 0, 1, 1. 2 is the sum of 1 plus 1. 3 is the sum of 2 plus 1. All the way down to 89, which is the sum of the two preceding, 55 and 34. And you can see B is basically the same, except for it doesn't start with 0, it just starts with 1 and 1, but it still sums up the same way. Okay, so for our next example, let's create a function that will display the Fibonacci sequence using recursion. Okay, so we used the def reserved word to create our function. We gave the function the name Fibocursive, short for Fibonacci recursive. It takes one argument, which is n. Then we said if n is less than 2, return that number, and that will help us to start our sequence out with the correct sequence of numbers. Then we used an else, and we return the recursive part of the function. And in this case, we're going to call the function, and inside the round brackets, we're going to put n minus 1, and then we're going to add that to the function that we call again, and inside the round brackets we're going to say n minus 2. And this code right here is the brains behind what makes this sequence come out as the Fibonacci sequence. And we'll show you the pattern of how this works here in just a second. Okay, so to display this, let's use a for loop here, and then let's use a print to display the numbers. So let's go ahead and select our code and run it. And you can see over here in the console, we get our Fibonacci sequence. Okay, so we mentioned that we would show you the pattern of how this is working. And this is a little bit more complicated than the previous examples, and it may be a little bit more difficult to understand. But if you want to see the pattern, we put in a print statement here. Okay, so you can see each time it goes through the loop, how this recursive function is working. And recall that recursion is a method where the solution to a problem depends on solutions to smaller instances of the same problem. So you can kind of think of it as when a function calls itself until the answer or answers are given. So let's go ahead and uncomment this print statement. Let's clear our console. Let's change our range a little bit because the output for this will be quite long. So let's go ahead and select our code and run it. And you can see that the output, as I mentioned, is quite lengthy. But if you wanted to understand that pattern, you could just look at this output over here, and that would help you to understand this code and how this recursive function is working. So that's all we have for this Python tutorial on the Fibonacci sequence. We will be doing many more Python tutorials in the near future. Join us for those, and we'll see you next time.